Assalamu alaikum and good morning. My name is Omar Ahmed Muhammad and I'll be presenting the first part in our presentation of real-time robokar in path execution using concurrent programming models. As we can see here, this is our team members and we are from section 4, team 8, Pingu. So, the integration of real-time embedded system in robotics has become increasingly important due to the need for precise, reliable, and responsive control of complex tasks. This project focuses on development and analyzing the Robocar, a mobile line following robot designed to navigate using a set of onboard sensors. The main objective is to demonstrate how real-time operating systems, or RTOS, and concurrent programming principles can significantly improve a robot's ability to handle multiple tasks at once. So for the first part, we are implementing the robocar without using the RTOS, and in this first version of the implementation, it runs without using any operating system real time, and the main control system is run through a single basic loop with simple sequential program. Since there is no task prioritization, Robocar cannot react instantly when conditions on the track change, and it manages to follow the line and finish the course. But it does it so slowly and less smoothly. In testing, the Robocar without RTOS completed the track in more than 150 seconds, which is generally slower with clear delays when handling turns and quick adjustments. So this was my part of the presentation. Now we'll be moving on to the next team member. Thank you.
In the improved version of Robocar implementation, we run it using RTOS, where the main control system is divided into multiple tasks instead of relying on a single basic loop. Basically, this task includes sensor reading, motor control, and navigation logic, where each running independently, which assign priorities. So with task prioritization, Robocar can react more quickly when conditions on the track changes and still follow the lines and complete the course in a more smoothly and efficiently way. So based on our testing, Robocar with RTOS completed the track in less than 100 seconds, showing faster response during turns and better performance in handling quick adjustments. So next I will show you guys about the examples of RTOS implementation. So for our project, we created 5 different tasks with 5 different prioritizations. So we have the start, the for check, and then we have check collisions, the control models and navigation, and lastly the light blinking task. So we created we defined 5 of them in different prioritization based on how important they are, and then this allows the real-time multitasking, which enable the robot to handle collisions, motor control, and navigation more efficiently. So next, the concurrent design and implementations. In the RTOS-based robot system, concurrent design means breaking down the robot functions into multiple independent tasks that run simultaneously. So basically, each task is responsible for specific operations such as checking for obstacles, controlling the models, handling navigation logic, or blinking an LED. These tasks are usually managed by RTOS using priority levels as shown earlier just now, and separate stacks, where this allows them to operate concurrently without interfering with each other. So this approach also ensures that time critical actions like avoiding collisions or adjusting directions are handled immediately without being delayed by less important tasks. So last but not least, the implementations that I mentioned earlier. So We have the check collision task where it detects obstacles using the proximity sensor and it executes avoidance maneuvers such as reversing or turn left, turn right, so it can go back on track. And then next we have the control model task where it will controls the mortals and applies the speed based on the speed that we set at regular intervals. And then lastly, we have the navigation task, and this one is the most important one as it handles the line following checkpoint detections and it makes decision based on which route we take and based on the sensors such as the 011 or 101. Then it will update the current state and changes the code that we wrote to better routes.
After all the team members' efforts, our group's robokar is eventually able to run smoothly and complete a full line track. Here is the demo video of our group's robokar. First, I would like to show the robokar without RTOS, which could not run properly. Now, let's take a look at the robokar with RTOS, which is able to run successfully. You can see the robokar without RTOS takes more than 150 seconds to complete the entire track. To be precise, it is even hard to do so. In contrast, the robokar that implements concurrency programming with RTOS completes the track efficiently in approximately 80 seconds. This difference is because the robokar without RTOS was developed using a simple loop that executes tasks sequentially. As a result, the program is not responsive or intelligent as it cannot perform multiple actions at the same time. On the other hand, the robokar with RTOS is able to process and execute different tasks simultaneously, such as controlling movement, detecting the line, and sensing the lights. The program prioritizes tasks using real-time scheduling, which allows for faster reactions and more efficient navigation.
And lastly, we are going to talk about the game day. The robokar game day was held on the 24th of June, Tuesday, at the N28 Faculty of Computing Student Lounge. Our robokar has successfully completed the checkpoints from start to E within 78 seconds. However, it encountered an issue between checkpoints E and F, where it went off track and could not finish the full course. Despite this, the robokar performed well throughout the earlier sections. Participating in this competition enhanced our knowledge of real-time software by allowing us to apply it in a hands-on way to control a physical robot. It also broadened our insight into a real-life technologies and their role in helping us being a better understand the concept. That is all from us. Thank you.